Here we are taking some examples of error in measurement. So here is our first example, that is a diameter of a thin wire is measured with screw gauge. In successive measurement, the values of the diameter of the wire are 2.04 mm, 2.06 mm, 2.08 mm, 2.07 mm, and 2.05 mm. So find average diameter of the wire, absolute error, and error abs- mean absolute error. So here is our measured values. These are the measured values. We have to find out the average diameter of the wire, that is the mean value, and we have to find out absolute errors and mean absolute errors. And we can also find relative error. We can find relative error, and we can also find percentage error. Percentage error. So first we have to take average diameter of the wire. So we have to just take the mean of or average of these measured value. So it will be av- average diameter. Yeah, the average diameter and mean value are same term. So it will be equal to a mean, that will be equal to sum of the measurement 3, 4, 1, 2, 3, 4, 5 times 5 upon number of, that is 5. So this will equal to a mean will equal to 2.04 mm, 2.06 mm, 2.08 mm, 2.07 mm, and 2.05 mm upon 5. Now after calculating we get 2.06 mm. So our A mean or average diameter of this wire is 2.06 mm. So here it is. Now second is we have to find out where we have to find out the absolute errors. Okay, so here is our mean value. We can treat it as true value. So that absolute error is what? Mean value minus individual measured value. So our mean value is a mean is 2.06 mm. Now absolute errors. This will be equal to first a1 delta a1 is a mean, we can write as am minus first observation, first measurement. Okay, and this will be 2.06 minus 2.04, and this will give you 0.02 mm. Second, a2 equal to am minus a2. Okay, so our am is mean value is 2.06, and a2 is a2 is 2.06. So it is minus 2.06, so 0. Now third absolute error is a3 equal to am minus a3 equal to 0.06 into 2.06 minus 2.08, and this will give you minus 0.2 minus 0.02, but in absolute error we only take magnitude, so that's why it is 0.02. a4 will be am minus a4, and this will be equal to am is 2.06 minus 2.07. 07 is the value of a4, fourth measured value, and this will give us 0.01 mm. So here it will be minus 0.01 mm, but in absolute error we only take magnitude. a5 del a5, that is equal to am minus a5 will be equal to, so 6 minus 0 5 equal to 0.01 mm. Now these are the absolute error. Now we have to find out mean absolute error. So our mean absolute error is what? Mean absolute error is the mean of absolute error. Mean absolute error means the mean of absolute errors. Absolute errors. So just we have to find out the mean of these absolute error. So it will be equal to delta A1, delta A2, delta A3, delta A4, delta A5 upon 5. So mean absolute error is del mean, or we can also symbolize it like this, del A. Okay, so this will be equal to 0.02 plus 0 plus 0.02 plus 0.01 plus 0.01. So these are the values. We have to just find out its mean upon 5, and this will give us 0.06 upon 5, and this will be 0.012 millimeter. It is the mean absolute error. Now we have to find out relative error. So our first, second, fourth one is we have to find out relative error. Relative error is equal to mean error, mean absolute error. Okay, mean absolute error upon mean value. Mean value, that is AM. So this will be mean, our mean absolute error is 0.012, and our mean value is 2.06. So this will give us 0.0058. So that is our relative error. And now 5, percentage error, just we have to multiply 100% with relative error, and this will give us percentage error. So means here if you multiply this with 100%, we can get our percentage error. So 0 point, this, the relative error is that much, so we have to just multiply this quantity, this number with 100%. 8 into 100%, and this will give us 0, that will be 0.85%. That is the relative, that is the percentage error for this case. Now our next question is the time period of oscillation of a simple pendulum is an experiment. So here in, not is in. So the time period of oscillation of a simple pendulum in an experiment is recorded as 2.56, 2.62, 2.70, 2.58, 2.45 respectively. Find the time period absolute error in each observation and percentage error. So we have to find out the time period. So time period, there is no actual value is given, so we have to find the mean value, that will be our time period, and then we have to find out absolute error in each observation, then we have to find out the percentage error. This one is also same compared to previous question. So here if we want to find out the time period, we have to take the mean value. So here mean mean time period of the simple pendulum will be equal to, or we can write as am is equal to 2.56 plus 2.62 plus 2.70 plus 2.58 plus 2.45. Okay, now upon 5, 1 2 3 4 5, and this will give us around 2.58 second, 2.58 second. Now this is our mean value. It is our what mean value, am mean value, we can treat as actual value. Now we can find out the absolute errors. So here absolute error in each observation, absolute errors, absolute error in first observation, that is delta a1 will be am minus a1, and this will be that much, 2.58 minus 2.56, and this will give us 0.02 second. Second a2, same am minus a2, 2.85 minus 2.62, that will give us minus 0.04 second, but we have to take that magnitude, not the sign, so that is 0.04 second. Next one is our a3, and this will give us magnitude of 0.12 second. A4, and this will give us 2.85 minus 2.85, that will be 0 second, and delta A5, this will give us AM minus A5, that is 2.85 minus 2.45, that will be 0.13 second. So here these are the absolute error. Next one, we have to find the percentage error. So for finding percentage error, we have to find first mean absolute error, then we have to find the relative error, then we can find that percentage error. So mean mean absolute error is what? We have to take the mean of these absolute error. So हमको ये सब का क्या mean निकालना होगा. We have to find out mean of these numbers, these measurements, these errors. So mean delta mean, that is the mean absolute error. It is the mean absolute error. So that will be equal to a1 del a1 plus del a2 del a1 plus del a2 plus del a3 plus del a4 plus del a5 upon 5. So first one is 0.02 plus 0.04 plus 0.12 plus 0 plus 0.13 upon 5. This will give you 3 to 5, 5 here, 5, 9 to 11, 3 upon 5, and this will give us 0.0627. So this is the mean absolute error or average error for this observation. Now we have to find percentage error. So percentage error, basically percentage error is what? Relative error into 100%. So relative error is what? First we have to put mean absolute error upon mean absolute error upon mean value. So here is 0.062 and our mean absolute error is what? 2.85. So upon 2.58 into 100%, and this will give us around 2.4%. So this is our percentage error. Now how can we write the range of error? So here our mean value, here mean value, we can treat as a true value, like true value. So it is what? It is 2.58, and our error in this case, mean absolute error is what? 0.062 is our error here. So we can write as range of this error is a, that is a a mean. So this can be written, we can write as 2.58 plus minus 0.062 second. This is our measured, mean value. We can treat it as true value, and this is the error. Thank you.